Hello, my name is ColynL, and this is my final project for INF 496. I developed a 3D printable and 3D printed lacrosse butt end that is used to stop your hands. Um, and so this is to bypass the retailer version, which is a bit clunky and quite honestly not too reliable. Um, yes, the model is more fitted and it's easier to navigate on the lacrosse stick, but oftentimes we as lacrosse players lose this piece or completely take it off. And so I decided that I would figure out a way to create my own version of it. And so thankfully we had the makerspace downtown and had a very supportive intern staff there, which really helped me develop this and made the process easier than it was, because honestly I wasn't too experienced with creating my own things from scratch. Yes, I took INF 301 and in 496 we did some 3D printing of our own, but nothing as crazy as this, or not as crazy as this, but just nothing that I had to individually find a problem and solve it myself. And so initially I used this retail version from Maverick Lacrosse, which is our sponsor here at Albany, where we get all our sticks and lacrosse heads, and they supply their own butt ends. But I, as a lacrosse player, don't really like this too much, and I find it's a little bit wanky. I don't know if it's a word, but I just don't really like it. And so I decided to create my own version of it. And yes, it's still in the prototype phase, but it's successful. It works. It stops your hand completely, and it does what it's supposed to do. And so that was the real goal of this project, and honestly didn't think I would be able to have this finished product, because in the beginning phases, as you'll see, it was kind of But so to start with, I used Sculpey, which is a type of molding clay, and I use the clay to mold and just get acquainted with the lacrosse stick and the butt end and how it would fit and look and feel. And so, I used the clay to kind of get a feel for the shape of the inside, which was the main problem throughout this whole process, because it's really hard to be accurate with a shape that's hard to measure. And so after I did this clay and I got a feel for the shape, this is the mold of the inside of it, this is around the shaft, and I have more, but I left them at home. But so this was a really tough variable to measure, because not only is it different in shapes and jagged lines, but it's hard to measure the inside from point A to point B. And so at first I used a caliper to find a range of the object and the sizing of it and how far point A was from point B, and the height, sorry, and just all of this fun stuff. And then I started to develop my own models in Tinkercad and eventually Fusion. But Fusion is very, very difficult. And yes, there's tutorials and they do help. It's still like just tough to navigate through all of the controls and just everything. And so it was a real tough battle with Professor Lazinski to allow me to really focus on Tinkercad, because it is easy to do things like this where it it's easier to create my own shapes, and it has their own presets already. And I'm sure if I really mastered Tinkercad, it would have been easier to create my own version, but it was tough. And so Tinkercad and Fusion were both used in the process of making the final product. But you'll see I'll continue to. So we have the first models, and not this one. These two are the main, and you can see they're huge. They don't really go with the shape too well, and so it's kind of they fit, yes, but they don't stay snug onto the shaft. They're easy to move off, and this one's locked down there. Same with this one. This one is just easy. And so we continued to go through this process and find a very snug fit, but we couldn't. When I say we, I mean me, myself, and Ian Jeffy. I think that's how you pronounce his last name. I'm not the best with last names. I know it's Ian though, because he really helped me throughout this process. He's an intern at the Makerspace. But so yeah, I was kind of going back to the drawing boards until one week in class we had an outside mind give us an idea to trace the actual shaft onto a piece of paper and Photoshop it, the image, and cut it through there and export the JPEG into Tinkercad in order to make an STL. I don't think that's the right process order, but that same method, and then just cutting up that file and making it look like a solid piece in Tinkercad and going from there. And so we kind of got this concave angles into Tinkercad, because it's really hard to manage angles and lines in Tinkercad. Fusion is way easier for that, but it's more complicated. And so this was the second phase of the creating the prototype butt end, and it was just a matter of just getting it to the right size, because then the shape is there. Now it's just getting the size that fits the shaft in a snug form. And so you can see it's still the shape there, but it's too wide and too big. And so it's just we went through a lot of instances with this. This one was another example of a very successful one. It fits. It stays on. And so it's not as really tight as this, but it was the most successful before this last print. And then I started to mess around with the variations of it and just how small this is compared to these ones where they're huge and more customizable. And it was just getting the right the right measurements for this final product. And so at the end we had the successful prototype. And so, yeah, it's not the final version, but it's the closest it'll get right now, just because of time, and I'm glad it worked out. And it really helped, and it was a long process. And this is just an overview of the whole process, but yeah, this is the final product, and hopefully one day more lacrosse players will be able to use this and just go to their local 3D printer and print out their own butt end, because it is a hassle to lose the original, and this is not customizable. This is, it's higher, thinner, it's easier to just have, and it's more concealed in a way. But yeah, it's just a very successful, and I'm very glad and proud I was able to do this. And so, thank you.